Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to see what is the actual application of the infrared spectrum, that is to identify the functional groups. So what we are going to do is we are going to interpret the different infrared spectrums that is respective for different functional groups, and what we will do is we will try to understand the key or important peaks that are specific for a particular functional group. Okay, these are some of the functional groups. We are going to see all of the functional groups, and this is how a infrared spectrum looks like. So the first most simplest functional group that you can identify is alcohol. So what you can do is you have to remember this number, that is 3300 centimeter inverse, because there are three functional groups that you can identify in this region. One is alcohol, okay, another is alkyne, okay, and third functional group is amines. Okay, so let us see first for alcohol. What we will get is, for alcohol what we are going to get is, one is we will get a broad peak. What is the meaning of broad and sharp? Okay, this is called as a broad peak. Okay, it is spread over a larger stretching frequency range, called as a broad peak. And one which is very sharp, okay, pointed, that is called as a sharp peak. Okay, why this is broad? Because of the hydrogen bonding that we are going to see in the next video, that is the factors affecting stretching frequency. And in alcohol, if you see, suppose I take CH3OH, there is another bond, that is CO bond, very important. CO bond stretching frequency we get to see at around 1300. Okay, so we get broad peak for alcohol. Second is amines. Now amines are of three types, we know. One is primary amines. Okay, another is secondary amine. There are two R groups. Okay, and the third is tertiary amines, R and R dash. Okay, so primary, secondary, and tertiary. How do you differentiate between all these three peaks? First of all, for amines, again you will get a peak at 3300, but the only difference here it is going to be a sharp peak. Okay, it is not a broad peak. So in this way you can differentiate alcohol and amines. Okay, so what are the different types of questions you will get based on this? Either you will be given an infrared spectrum and they will tell you to identify the functional group, okay, or they will give you two different compounds and they will tell you how you can differentiate the two compounds using infrared spectrum. Okay, so amines, first is you will get a sharp peak at 3300. Okay, for a primary amine, we will see in a moment. For primary amine, there are two bending modes: stretching, symmetric stretching, and asymmetric stretching. So what you get is, you get a doublet like this. Okay, for a primary amine, RNH2. Okay, since here there are two NH bonds, stretching is possible here, and you will get a singlet, that is a single peak in case of a secondary amine, because in secondary amine there is only one NH bond. Okay, there is only one NH bond. Okay, this is for the amines. Next functional group, the third one which I was talking about, is alkynes. Okay, now alkynes, if you see the basic structure of alkyne, suppose I take ethyne, there are two important bonds that you can see here. One is this carbon carbon triple bond, and there is this CH bond. So this CH bond of alkyne, we see what? We see a sharp peak at 3300 centimeter inverse. Okay, so now the question is, a very important question is, so this is also giving a sharp peak at 3300, and if you see amine, the secondary amine is also giving a sharp peak at 3300. Now the question is, how will you differentiate between amine and alkyne? So in alkynes, along with this peak, you will see another sharp peak at 2200. You will see at 2100. Okay, 2100 centimeter inverse. You will see another peak for C triple bond C. If you get both these peaks, it will be alkyne, and if you see only one peak, that is only at 3300, there is no peak at 2100, then you can say it is amines. Okay, so in this way you can differentiate amines and alkyne. Okay, alkyne you will see two peaks. Okay, so alkynes you can see a sharp peak at 3300, and for carbon carbon triple bond we can see at 2100 centimeter inverse. And cyanides you will see a peak for C triple bond N, that is around 2200. So this is very important. Okay, there are two peaks in the range of 2100 to 2300. One is the peak at 2100 centimeter inverse, and another is around 2200, that is around 2250. Okay, lower value, this is for carbon carbon triple bond, and this is slightly higher, this is for carbon carbon nitrogen triple bond, that is cyanide. Okay, and we know this is more electronegative, this is more polar, that is why we are getting what, higher stretching frequency. We had seen in the last video that the stretching frequency depends on what, it depends on the polarity. CN bond is polar, CC triple bond carbon carbon triple bond is non-polar. Okay, so these were some of the very important peaks in the range of 3300 to in the range of around 3300. So now let us see actual IR spectrum to understand the peaks. So OH for alcohol, you can see this broad peak that you can see here. This is for what? This is around, you can see this is 3000, 3500. So this is around 3300 centimeter inverse. This is for OH. Okay, this is which functional group we are talking about, alcohols. Okay, this was for alcohol. Next is second primary amine. So you can see here primary amine, there are two NH bond, and you can see a doublet like this as shown here. Around, again this is around 3300. Next is, okay, so the question is, why do you get a doublet? I had told you this, it is because of the two stretching modes. One is symmetric stretching, that is around 3300. Okay, this is for symmetric stretching, okay, at around 3300. Okay, and this second peak you can see, this is for asymmetric stretching at around 3400. 3400, this is 3300 centimeter inverse. This is what, this is stretching modes we are talking about. Okay, stretching, this is also stretching. Okay, so this was about primary amines. Now let us see secondary amine. Secondary amine, you can see there is only one NH bond and a sharp peak at around 3300. Okay, this was secondary amine. And this is what, this is tertiary amine. Okay, tertiary amine. So you can see here there is no peak at 3300. This is 2000, this will be 3000. So around 3300 you can see here there is no peak. Why? That is a question. Why you cannot see any peak? Because there is no NH bond that is present. Okay, no NH bond that is present. Okay, we saw in primary and secondary, I mean this was for, these peaks were for NH bond. Okay, NH bond is absent, so how will you see the peaks? Okay, so for tertiary, I mean there is no peak that you can see here. Now the next compound is alkyne. Alkyne you can see here. This is again a sharp peak at 3300 for this CH bond that is highlighted. Okay, and along with that, I told you for carbon carbon triple bond, this bond you will see the peak at around 2100. As you can see here, this is 2000. This is the peak for carbon carbon triple bond like this. Okay, so I hope you have understood the three functional group: alcohol, cyanide, amines, and alcohol, cyanides, amines, and alkynes. Okay, now in carbon carbon triple bond also, if you see this compound, there are two types of alkynes. In case of carbon carbon triple bond, alkynes can be of two types. One is where you have a terminal, okay, double triple bond is present at the terminal position. For example, CH3 C triple bond CH. Okay, this is called as terminal alkynes. And there is another type of alkynes like R, C double bond C, other position also there is some R group. So here if you see example is this C triple bond C, let's say here there is CH3. So you can see this is called as internal alkyne. Why? Because here triple bond is present in between the carbon chain. It is not present at the terminal position. So for terminal groups, you can see the peak at 3300. But for an internal alkyne, as it is given here, for an internal alkyne, you can see there is no peak for CH. Okay, for this CH bond also, we cannot see any peak. And carbon-carbon triple bond also peak is not visible. The question is why it is like this, right? So for asymmetrical, for an internal alkyne, what happens is for an internal alkyne, the change in the dipole moment is very minimum. Okay, the change in the dipole moment or change in the bond length is very minimum. Change in the dipole moment is minimum or it is negligible. So that is why very less stretching or negligible stretching occurs in case of internal alkynes. So you don't see a peak at no peak for carbon-carbon triple bond as well as for CH. Okay, SpCH. You can call this as Sp because carbon here is Sp hybridized. So we can say SpCH. Okay, so this was about alkynes. Okay, so here you can see for nitrile you will get the peak at 2250. For alkyne you will see the peak at 2100. So these are the two important peaks in the triple bond region. Okay, in the triple bond region. So this is a summary of all the functional groups we had seen till now. At 3300 we see three functional groups. One is NH, okay, secondary amine. Okay, and then for primary amine you see two peaks, okay, doublet, the green one. Okay, secondary amine is this brown one, and one more functional group alkyne SpCH. Okay, CH bond of alkyne you see again at 3300, plus for alkyne we see triple carbon carbon triple bond peak for carbon carbon triple bond at 2100, right? Another important peak that we see at around 3000 is for CH. Okay, around 3000 you will see for CH. So that also we can see here. Okay, I'll show you at the end. We'll see this. So there is some peak. Okay, this is 3000. Okay, sometimes you will see a peak slightly lower. Okay, slightly lower than 3000. Okay, let's say this is 2900. Okay, this will be for CH bond of aliphatic compound, or we can say alkane. Okay, that is sp3ch. You will see here, suppose there is methane. Okay, methane, here there are CH bonds that will be seen. The peak for this bonds will be seen at 2900, slightly lower than 3000, and you will sometimes see a peak that is slightly greater than 3000, that is, let's say, 3050. These are for CH of the aromatic compounds. Okay, that is which peak? That is for the benzene. Okay, aromatic means benzene ring. You can see here there is this CH bond. Okay, this CH bonds you will see the peak at slightly higher than 3000, that is 3050. So this is very important peak because it will be useful to identify whether aromatic compound is present or not. That is whether benzene is present or not. Okay, so this peak is very important, slightly higher than 3000. It is for aromatic CH, and slightly lower than 3000 it is for aliphatic. Okay, aliphatic or straight chain alkanes. Okay, so these are some of the important stretching frequencies. Now we are going to see another very important class of compounds, that is carbonyl compounds. And why these are called carbonyl compounds, we know because they have what? They have a carbonyl functional group. This is what this is called as carbonyl group. So carbonyl functional group, it is around 1700. It is seen around, peak is seen around, a very sharp peak will be seen at around 1700 centimeter inverse. So all the carbonyl compounds have the carbonyl group, right? So the question is, will all the carbonyl compounds have the same infrared spectrum? The answer is no, because there are, apart from carbonyl group, there are some other bonds as well that will be helpful to differentiate between different carbonyl compounds that we are going to see now. So the simplest carbonyl compound is ketone. The ketone, you can see here there is a peak at 1718, that is around 1700. This is for carbonyl, as it is written here. This is for ketones. So very important, you have to remember that you get a peak of carbonyl at 1700. This number is also very important, that you have to remember. 1700 is for carbonyl group. Okay, and CH stretch we had seen just now. It is, you can see 3000 is around here, so slightly lower than 3000. This is what sp3ch for aliphatic compound. You can see here, this is aliphatic group. For this you get ch peak at slightly lower than 3000. Okay, this was for ketones. Next is aldehyde. Now, how will you differentiate ketone and aldehyde? Aldehyde, you can see carbonyl group is present, fine, that is same around 1700. This is same for both aldehyde as well as ketone. But there is an extra CH bond, you can see here. That CH bond you will see at around 2800, 2700 to 2800. Okay, for aldehyde. For aldehyde, we see peaks at around 20 to 2700 or 2800. That is for aldehyde function. Okay, so in this way, this will be an extra peak around 2800 for aldehyde group, okay, CH bond. Okay, the third important compound, carboxylic acid, is very easy to identify. From 2400 to 3600, 3500, 3600, you will see a very broad peak like this, broader even. Okay, for alcohol you have like slightly uh, semicircular, you can say, for OH, but this is the OH peak. Okay, this is for the OH of the carboxylic acid. This is very broad because here also you will see, we can see extensive hydrogen bonding. Okay, extensive hydrogen bonding is present in carboxylic acid. That is why we see a very broad peak for OH of carboxylic acid, as you can see here. Okay, OH stretch, you can see it is very broad. Again, this is from, you can see this is from around 2400 to 3400, 3500. So if you see such a very broad peak, then it is for carboxylic acid. Again, carboxylic acid group also we have carbonyl around, for the carbonyl group around 1700. Next is ester. For ester, again you will see carbonyl group is present at around 1750. Okay, you can remember 1740 to 1750 is for ester. Okay, you get a slightly higher frequency for carbonyl group, that it will be for ester, 1710 to 1725. This range is for aldehydes and ketones. Carbonyl stretching frequency, this is for aldehyde and ketone, that is around 1710 or 1720. Okay, plus you can see in ester there is this CO bond. Okay, CO bond is present. So for CO bond we had seen in alcohol also, if you remember. Okay, alcohol also you can see this CO bond, COH. Okay, this CO bond we had seen around 1300, and then OH bond broad peak at around 3300. Okay, so here for ester there will be this extra peak at 1250, 1250. Okay, so in this way you can distinguish ester. Next is amide. Now the question is, here also this NH2 group is present, and in primary amine also we had seen there is NH2 group that is present. So how do you differentiate amide and amine? This is a amine, right? Primary amine. So here you can see there is one extra carbonyl group. So with the help of this carbonyl group, you can identify. So for NH, a primary amine, you can see there is a doublet. Okay, that is for two stretching modes of vibration. And there is another peak at around 1660 to 1630. Okay, that is for carbonyl group. So you can see both peaks for carbonyl and NH is present. Only NH is present, it will be primary amine. And if both are present, peak at carbonyl as well as NH, then it will be amide. Okay, peak for both NH and carbonyl, amide, only NH bond, then it will be primary amine. Okay, so next is alkenes. Alkenes, very important. Alkenes, you will see two types of alkenes. One is aliphatic. Okay, that is around 1650. Okay, and there is another carbon carbon double bond is present in benzene as well, right? So for aromatic, you will see around 1600, slightly lower. Okay, so for alkene, this is aliphatic alkene, you can see around 1650. Peak at around 1658 is for carbon carbon triple bond. Okay, and this CH peak of alkene, this is also seen at around what? At this peak, at around 3100. Okay, this will be seen at around 3100. Okay, and finally, aromatic. So this we had already seen. CH of aromatic is slightly left of 3000. That is this. Slightly higher than 3000. This is for aromatic compound. Okay, CH of the benzene. Okay, this CH bonds. This CH bonds is around 3000, 3068, 3099. Okay, and this aliphatic CH or alkyl group CH, you can see slightly lower than 3000, that is 2900. That is for sp3CH, that is aliphatic CH. Okay, aliphatic CH. So this was about alkenes. This you have to remember. Very important. Two peaks CH, one is aliphatic, another is aromatic. Okay, so this is a summary of the double bond region. Carbonyl, we can see between 1750 to 1650, depending on the type, means depending on the functional group. Okay, based on the different types of functional group we had seen, you will get different carbonyl stretching frequency. Alkene, okay, alkene you can see, aliphatic alkene, this is around 1640, and aromatic is around 1500 to 1600. Arene means benzene, okay, aromatic compound. Aromatic, or we can say arene. Benzene is also called as general name for benzene is arene. Okay, so this is a peak for what? Carbon carbon double bond. Okay, this was for the double bond region. Now last there are two compounds. One is nitro. Now nitro, if you see, I can draw resonating structures like this. So what will be the resonance hybrid? Resonance hybrid will be like this. So both the NO bonds are what? They are equivalent. So again for NO2, okay, for two NO bonds, you can see there are two stretching. One is symmetric stretching and anti-symmetric, just like we had seen in the amines. Okay, just like in primary amines, we had seen symmetric and anti-symmetric. Here also there are two. One is symmetric and another is anti-symmetric. Okay, one is the peak at 1350 is for symmetric stretching, and slightly higher peak at 1500 is for anti-symmetric stretching. So let us see the peaks. So at around 1350 is for symmetric stretching. Okay, which bond we are talking about? N double bond O. Okay, and around 1550. Okay, this is 1400, 1600. So this is 1550. This is for anti-symmetric stretching or asymmetric stretching. Okay, this was for the nitro compound. Okay, and also remember in this region, one more bond is present, that is CO. If CO bond is present, that is also around 1300 centimeter inverse. That we had seen in alcohols and in esters. Okay, last is alkyl halides. Alkyl halides, CBr bond. Okay, the specific bond for alkyl halides is what? CX. X is what? Halogen. It can be fluorine, chlorine, bromine, or iodine. So here we are seeing CBr bond. CBr bond you can see in the fingerprint region, that is very low. It is around 651. And CCl bond, carbon chlorine bond, you can see which is around 743. This is also in the fingerprint region. Fingerprint region we had seen it is from 600 to 1400 centimeter inverse. Okay, so this is the end of this video. I hope you have understood how to distinguish or differentiate between different functional groups and how to exactly identify the infrared spectrum. And the main aim of this is to identify the functional groups, or the second type of question, if two compounds are given, how to distinguish between both these compounds, okay, using the infrared spectrum. So you have to see which peak will be present, which peak will not be present. For that you have to look at the molecule very carefully, then only you can identify and carefully analyze the infrared spectrum. In the next video, we will see the different factors that affect the stretching frequency. Thank you so much.